So in the previous class, we studied about the two modelings in the Verilog HDL. We started with the data flow modeling and the gate level model. The data flow model, which specifies the Boolean expression using the assign statement. Using assign statement, we return the program for the given Boolean expression. That is for data flow model. Then for gate level model, the gate level model specifies the interconnection of gates or modules or blocks, I can say. The interconnection of gates, how it is connected or how the input and outputs are mapped between one module to another module or one block to another block. That is what we studied in the previous classes. So now what is along with that, we seen so many examples only for the combination circuits we seen. Still now we didn't gone for the sequential circuit, how we have to write in that. So even we can write the sequential circuit also. Let us go for the combination circuit only, then later step by step we'll go for the sequential circuit also. So now next what you'll do, we'll go for the next module, that is nothing but the gate level module. Next module is gate level module. Let me go for the it's a behavioral model. The next model is behavioral model. So now, which specifies specifies the logic of the circuit, or for a given response, it will produce the output. Let me take an example how this will work out, the behavior model. So what we will do, let us take here one simple block. He doesn't know what it is. Say example, let me take like this. This is the block, this is the input, this is the output. So now this is the input, this is the output. Now we doesn't know what will be inside, but we know for a given input we get the output as like this. Say example, I'll say when I give the input as 0 0, I may get the output as 1. When I give the input as 1 0, it may produce the output as 0. When I give the input as 0 1, it may give the 0. When I give the input as 1 1, then it may give the output as 0. See, I doesn't know this circuit which will produce based on which logic expression. Only thing is what you do, you only or the programmer only has to specify the given input as well as the output also. Remember, in the previous cases and all, we'll feed only the input, but inside the program, we'll say like this: when the input is 0 0, then the output is 1. So both you are only going to specify. But you may see, based on this, I can say what kind of the circuitry or what kind of the logical expression it will execute actually. So based on this truth table, I can say this is nothing but the NOR gate actually. This is the NOR gate actually. So like this, we have to frame the specification. So now the other specification, I'll say, the one more specification is like this. You can consider in this way. So you have to write the Verilog code. It's like this only. Just I will say the question. No need to write down the question. Just listen what I'm saying. Now what you have to do? You have to design a circuit. Design a circuit. The circuit has 3 input and 2 output. Example I'm saying. Okay. In that, so all the in the inputs, if any one input is high, then in the output, let's say example, I may take output as x and y is the output. Any one input is high, x is high, y is low. Next, if any 2 input is high, x is low, then y is high. All the 3 inputs are high, then my both outputs are high. This is the given specification for you. So how can I give the specification? Let me give you like this only. A, B, C, this is your input, then X, Y is nothing but your output. Now what I will do, what I said, any one input is high, correct? So let me write like this. one, the example I'm saying, see, any one, right? So I will say this is 0 0, any one is high, any one, for example I'm saying. So this is high, this will be low. Next, any two are high, any two, just I'm taking these two, 0, then this will be high, I said. Next, if all are high, then what will be? Both are high. This is the given expression I'm giving for you. But as you know, input is a 3 variable, means the total combination will be 8 actually. But I given the combination only 3. So you should put the permutation in the combination. You have to check the output. What will be the circuit? Can you predict what the circuit will be? This one. Is there any idea? Yes, Nega. Any idea? What kind of circuitry will be? Yes. Yes.
Adder circuit.
Yes, correct. It is a full adder circuit actually. It has 3 inputs, 2 outputs. You consider the x is nothing but a sum, y is carry. If you consider like that, so you put the other combination, everything the same output will get. So finally, we can justify this is the adder circuit. See, now what is it? We frame the question actually. We are not revealed what kind of circuit it is. We should identify what kind of circuit will be. The system may also identify what kind of circuit it will be. So like this only we are going to specify. Now what is our role here in the behavior model in the sense like, so how this here it will give for a given input response, the output also will get response. What is output you get? So inside this block will be empty. So you, for this empty block, we are going to write the code actually. So for that, what you have to do in the sense, we have to use the concept of the programming like conditional statements, loop statements, those kinds of statements and all we have to use here. That is what we are going to study in the behavior model here. So now first what I will do, let me go for initially start first example. Let me take a first example, simple example. Let's take what I will do. Let me write the Verilog code for of adder. Simple one, simple I am writing. Or I will write as Verilog code for 2 to 4 decoder. Example. Write the Verilog code for 2 to decoder using behavioral model. Yes. Now this is our question. Now before enter into that, we need to know the syntax for behavioral model. Let me go for the syntax of behavioral model. The same syntax only I'll write module declaration first, then input declaration, then output declaration, then here only we'll get extra additional. I am going to add a register declaration. Then the statement will be like this: always at sensitivity list, then begin statement, that is statement 1 I can say, statement 2 I can say. Which other statement will come here? In the sense, those are like this, like I'll say conditional statements, then loop statements, then like this statements will come, then finally end module. This is the declaration. So now here I'll say what are the additional things we did here in the sense. So we may see the one thing is this one, then additional is this one, Then this one. These are the special things here. Yes, see, these additional things we did. Now, let me go through how we have written. See, this one, which one? This one. This is common for all the module already we said. Module declaration, which will have the list of inputs and the outputs. Next day, input declaration we know, the output declaration also we have to. Next, register declaration, very, very important here in the behavioral model for each and everything. Like the registered declaration will be for only for output. That is very, very important. Register declaration. See, this register declaration is for specify the output variable. Specify the output variable which you declare in the output here. See here in this output, whatever the variable is given, the same variable we need to specify in the register also, especially for the behavioral model. Then here you see we must start with always. The very, very important. This is the keyword. The always is a keyword. Always is a keyword. Then followed by at. Then we can see here the one more important thing is sensitivity list. You see this? Now, what is the meaning of sensitivity list? The sensitivity is nothing but it will have the list of the sensitivity list will have only the inputs. The sensitivity list is nothing but here the input. Why you have to give only the input in the sense here? What it will do in the sense, always at whatever the variable I am giving in the sensitivity list. The meaning is it will sense the input. Means if there is any change in this variable, what is specified in the sensitivity list, then this statement will get execute. So now simple I can say when this statement will get execute, these statements will execute whenever the changes is happening over here. The changes in the sense what? Say example, you might have given a comma b comma c. Any one variable, if it has the transition from 0 to 1 or 1 to 0, that will be considered as change. So that will sense automatically the statement will get executed. This is what the meaning of sensitivity list. You cannot give output variable in the sensitivity list because the output will be produced. So it will sense only the inputs. That is very, very important. Next, you have to start with begin. See here, this is one of the very, very important thing. Now, this begin and end is simple. I can say, you remember your C++ program or C program. This begin will be equivalent to open brace. This end is nothing but is a close brace in the C++ program. Now you can remember when we will use the open brace and the close brace normally. If you are having more than one statement, then we need to use the open brace and the close brace. If you are having only one statement, then this open brace and close brace is not required. But even for single statement, if you use the single brace and that is the open brace and the close brace in the C program, that will not give you any error actually. So that is only even in the Verilog also, the open brace and close brace equivalent to begin and end. You have to be very careful. How many begin you done, the same number of end must be. So this will be begin and end. See, begin and end. Then always begin and end is that this end module is for your this module, end module. See the hierarchy. We have to close this begin, end module. You can have multiple begin and you can have multiple always statement also. See example like this also. See Multiple always statements also can be possible in the behavioral model. I hope now you might have understood. Now what I will do, let me go for the decoder program. Let me go for the decoder program. Yes. So now we'll see the decoder 2 to 4. We are going to write the program for this. For the given input, this is the output truth table we shown. Now module decoder 2 to 4, the inputs and outputs as per the truth table we are writing. A1, A0, D0, D1, D2, D3. Now next is input. Which are the input here? A1 is the input and A0 is the input. Next is output. Outputs are D0. Then D1, D2, D3. Now you see, as I said initially, what I'm going to do here, very, very important, we must to use the register, that is the REG. Reg is a keyword. It is a keyword actually. REG is a keyword, very, very important. Yes, sir. Reg, you must use. Which and all will be the register declaration? Whatever the output is specified, the same it has to come. See, D0, D1, D2, D3. See, this and all. So what I will make, this is. Yes, see. Register REG D0 D1 D2 D3. The REG is a keyword, very, very important. See, that is why I highlighted in the red color. This is the keyword for every program. When you're going to write in the behavior model, the register is must. The register will have the output variables, very, very important. Next, let us go for the always. Always. Even this also is a keyword only. Always at. Then open the bracket. Now here what it has to come? Sensitivity list. Sensitivity list in the sense it's an input. Inputs are A1 comma A0. This is you should not give the semicolon here. See, don't use semicolon here. Why? Because if we give the semicolon here, automatically what will happen? The process, this statement will get terminated here itself. Then nothing will execute here. So only we should not use a semicolon. This is the common mistake everyone will do. In the always they'll use a semicolon here. You should not use a semicolon. Next, after that what you'll do? You have to use a begin. Remember, I think it's a begin. because open the brace. Now let us start what kind of statement we have to use, right? So for that only what I will do, before entering into that, let me go what are the statements are there. So here statement, first let me try with the conditional statements. Conditional statement. Let us study about the conditional statement. To write the program here, I'll go right. Okay. The first conditional statement is if statement. The second conditional statement is. Now we are going to see the program using if statement and the case statement. So first, if statement. First in the if statement now. So now in the if statement, what and all is there? Now is simple. We can say first if, correct? So let me say 1. That is if. Second is if else. Third one is if else, that is I can say nested if statement. So here we have 3 different types of statements are there under the if statement. One is if, next is if else, next is if else if statement, that is nested if. Totally 3 things are there. Now what we will do, first we'll see the syntax for if statement. Syntax for if first. How the syntax will be there now for if in the sense, say example, if followed by condition in the bracket, condition, then begin statement, begin statement, then end again if it go like this. This is for if condition. Then syntax for if else. Syntax for if else now. If condition begin statements, then what you will do? And next we will go for else. Then what you will do? Begin statement, then end. I hope you might have understood now the difference between this and this. See, if condition begin statement end, then else begin statement end. This begin, this end, this begin and end is equivalent to in C program is a what? Open brace and close brace. There is no very important thing is here. Note in C++, there is no end if statement. In C also it is not there. There is a very important note. There is no end if actually. So now you see if condition, then after the condition you should not use any more semicolon also, even here also. Same is equivalent to your C program only. Next, syntax for nested if statement. Nested if statement. How it will be syntax now? Nested if statement. If condition begin statement end, here I will say else space if. See, else if else begin end statement. See, I think you might have got the difference. Syntax for if statement, if will statement, then nested if statement, like this only nested. So if condition is true, this will be execute. Else if, yes, here condition 2, next condition, right? Yes, let's see. Else space if condition again begin statement, and if this condition is true, then this will be execute. If this condition gets failed, then it will go and check this condition. If this condition is true, then this statement will get execute. Even this also gets fails, then it will go for the else statement. This will be executed. This is what the nested if statement. This is the three important conditional statement. In examination, very important. They will ask the conditional statements. If we are going to use this, we are going to write the program actually here. We are going to write.